Alright, so now let's go ahead and use the chain rule combined with some other rules. So let's take this function, h of r equals the square root of r squared times sine of r, and go ahead and find it. So our inner function, u, is equal to r squared times sine of r. And so to find our outer function, we rewrite h of r now as the square root of u. Instead of r squared times sine of r, we write u, so we get the square root of u. So we compute du dr. In this case, to compute du dr, we're going to need to use a product rule. We have r squared times sine of r. So we get 2r sine of r. We took the derivative of r squared and left sine r alone. Okay, so now we're going to have to add to it what we get when we leave r squared alone times the derivative of sine of r, which is r squared times cosine of r. So all of that is du dr using the product rule. And then we also need dh du, which is 1/2 u to the negative 1/2 using the power rule. Remember, we think of the square root of u as u to the 1/2 power. So let's put this all together. dh dr equals dh du times du dr. So let's fill in dh du. So we get 1/2 u to the negative 1/2 du dr. And now instead of u, we're going to fill in r squared sine of r. So we get 1/2 r squared sine of r to the negative 1/2. And then we fill in du dr, so we get times 2r sine of r plus r squared cosine of r. Notice that there are only r variables here. There are no u variables. And you should never have a u variable in your answer. So let's do another example. Let's take g of w equals 3w squared plus 7 to the w plus the square root of 11w. So when you look at this, you should think about what the fundamental operation is. What is the last operation that occurs if you are going to be evaluating this at some w value? So probably what would happen is you would compute 3w squared times 7 to the w, and then you would compute the square root of 11w, and very last you would add them together. So to do this, you need to use a sum rule to find the derivative. The sum rule says that the derivative of g is equal to the derivative of 3w squared times 7 to the w, and then you add that to the derivative of the square root of 11w. So let's do that. Okay, we're going to find each derivative separately. So to compute the derivative of 3w squared times 7 to the w, you heard that word times, and that's because this is a product, 3w squared times 7 to the w. So we're going to need to use a product rule. So we get 6w, 7 to the w. That's what we get when we take the derivative of 3w squared, and then we multiply it times 7 to the w. Don't do anything to the 7 to the w. And then we need to add to it the derivative of 7 to the w times 3 to the w squared, leaving that alone. So we get plus 3w squared times 7 to the w times the natural log of 7. Okay, all of that is the derivative of 3w squared times 7 to the w. So now we need to figure out what the derivative of the square root of 11w is. So we need to figure out what our inner function is and outer function. Why? Because this is a composite function, square root of 11w. It looks pretty simple, but 11w is the inside. I have to compute that first and then take the square root. So my inner function here, u, is equal to 11w, and my outer function is equal to the square root of 11w, or my outer function is the square root of u. And then so I get du dw is equal to 11, and dy du is equal to, well, of course, y is equal to u to the 1/2, so I get the derivative with respect to u is 1/2 u to the negative 1/2. So my derivative here is going to be dy du times du dw, which is equal to 1/2 u to the negative 1/2 times du dw, which is 1/2 times the square root of 11w, times 11w to the negative 1/2 times 11. Okay, so let's remember what we were doing here. We were taking the derivative of the square root of 11w because it was part of a bigger derivative. Okay, it was part of the derivative of g of w, which was a sum. This tells us that g prime of w equals 6w 7 to the w plus 3w squared 7 to the w times the natural log of 7 plus 1/2 11w to the negative 1/2 times 11. Okay, and there you have it. That's the end. There's our derivative. Okay, here's one that's left over. Why don't you see if you can try this? And then I will write down the solution to verify. So I'm going to pause. You go ahead and pause it, and then let me write down the solution. Okay, so here goes. We're going to use a quotient rule to figure out what the derivative is, because the fundamental operation, the very last one occurring, is that division, so we use a quotient rule. So to use the quotient rule, we take the derivative of the numerator, which is going to be 45 times 2 to the t natural log of 2, times the denominator, e to the square root of t, minus the numerator, 45 times 2 to the t, times the derivative of the denominator. So now we need the derivative of e to the square root of t. E to the square root of t is a composite function. You need a chain rule to figure out what the derivative is, so you need to do that off to the side. You should come up with e to the square root of t times 1/2 t to the negative 1/2. Okay, and now we divide all of this by the denominator, e to the square root of t squared. And there is our derivative. Just as an aside, if you want to know how I came up with this, if you don't, that's okay. I'm done. That's all I'm going to do is try to tell you how to find that. If you want to find the derivative of e to the square root of t, you first need to figure out what the inner function is. Our inner function is the square root of t. Our outer function is e to the u. And then so we have du dt equals 1/2 t to the negative 1/2. dy du is e to the u. So the derivative of e to the square root of t is dy du, which is e to the u times du dt. And this gives us e to the square root of t times 1/2 t to the negative 1/2. And that's how we came up with the derivative of the denominator.